Let's dive right into the fascinating world of trigonometric identities. Today, we are going to explore how we calculate the values of trigonometric functions for the sum and difference of two angles. These identities are fundamental because they allow us to simplify complex trigonometric expressions and solve many real-life problems, such as finding angles in geometry or physics. Now, let's look at the cosine of the sum of two angles. The formula is cos of open bracket x plus y close bracket equals cos x times cos y minus sin x times sin y. This identity comes from the unit circle and helps us break down the trigonometric values for the sum of angles. Let's visualize this with an example. Suppose we want to find cos of open bracket 60 degrees plus 30 degrees close bracket. We can use the identity cos of open bracket 60 degrees plus 30 degrees close bracket equals cos 60 degrees times cos 30 degrees minus sin 60 degrees times sin 30 degrees. Using the known values for sine and cosine, we get cos of open bracket 60 degrees plus 30 degrees close bracket equals 1/2 times square root of 3 over 2 minus square root of 3 over 2 times 1/2, which simplifies to 1/2. Next, let's look at the cosine of the difference of two angles. The identity here is cos of open bracket x minus y close bracket equals cos x times cos y plus sin x times sin y. This identity is derived by replacing y with minus y in the sum identity. It's like flipping the sign, and it gives us a new expression for the difference of two angles. Let's see how this works with cos of open bracket 45 degrees minus 30 degrees close bracket. Cos of open bracket 45 degrees minus 30 degrees close bracket equals cos 45 degrees times cos 30 degrees plus sin 45 degrees times sin 30 degrees. Plugging in the values, we get cos of open bracket 45 degrees minus 30 degrees close bracket equals square root of 2 over 2 times square root of 3 over 2 plus square root of 2 over 2 times 1/2, which simplifies to open bracket square root of 6 plus square root of 2 close bracket over 4. Now, let's look at the sine of the sum of two angles. The formula for this identity is sin of open bracket x plus y close bracket equals sin x times cos y plus cos x times sin y. This is another essential identity in trigonometry. It helps when calculating the sine of a combined angle and comes in handy in problems involving wave interference or alternating currents. Let's calculate sin of open bracket 30 degrees plus 45 degrees close bracket using the identity sin of open bracket 30 degrees plus 45 degrees close bracket equals sin 30 degrees times cos 45 degrees plus cos 30 degrees times sin 45 degrees. By substituting the values, we get sin of open bracket 30 degrees plus 45 degrees close bracket equals 1/2 times square root of 2 over 2 plus square root of 3 over 2 times square root of 2 over 2, which simplifies to open bracket square root of 2 plus square root of 6 close bracket over 4. Now for the sine of the difference of two angles, the identity is sin of open bracket x minus y close bracket equals sin x times cos e minus cos x times sin y. This identity helps when you need to find the sin of a difference, and it's particularly useful when dealing with phase shifts in physics or engineering. Let's apply it to sin of open bracket 60 degrees minus 30 degrees close bracket. Sin of open bracket 60 degrees minus 30 degrees close bracket equals sin 60 degrees times cos 30 degrees minus cosine 60 degrees times sine 30 degrees. We simplify it as sine of open bracket 60 degrees minus 30 degrees close bracket equals square root of 3 over 2 times square root of 3 over 2 minus 1/2 times 1/2, and we get 1/2. Next, we move on to the tangent of the sum of two angles. The identity is a bit more complex. Tan of open bracket x plus y close bracket equals open bracket tan x plus tan y close bracket over open bracket 1 minus tan x times tan y close bracket. This identity is key in simplifying expressions involving tangents, especially when you're working with multiple angles. Let's find tan of open bracket 45 degrees plus 30 degrees close bracket using the formula. Tan of open bracket 45 degrees plus 30 degrees close bracket equals open bracket tan 45 degrees plus tan 30 degrees close bracket over open bracket 1 minus tan 45 degrees times tan 30 degrees close bracket. Substituting the values, we get tan of open bracket 45 degrees plus 30 degrees close bracket equals open bracket 1 plus 1 over square root of 3 close bracket over open bracket 1 minus open bracket 1 times 1 over square root of 3 close bracket, which simplifies to open bracket square root of 3 plus 1 close bracket over open bracket square root of 3 minus 1 close bracket. Now that we've gone through the identities for sin of open bracket x plus y close bracket, sin of open bracket x minus y close bracket, cos of open bracket x plus y close bracket, cos of open bracket x minus y close bracket, and tan of open bracket x plus y close bracket, we've learned how these formulas simplify the process of calculating trigonometric functions for sums and differences of angles. These identities are incredibly useful in a variety of real-world scenarios such as signal processing, geometry, and even engineering. Let's quickly recap what we've learned. We derived the key identities for sine, cosine, and tangent of sums and differences of angles. These will help you handle more complex trigonometric problems efficiently. Now that you understand how these identities work, you'll find that solving trigonometric problems becomes much easier. I hope you feel more confident in using these formulas. See you in the next topic, where we'll dive into more advanced trigonometric applications.